Welcome to this video where we will show how to instrument a Lambda serverless function with OpenTelemetry in a step-by-step approach. But first, you should ask yourself, why should I do that? You will probably do that because you would like to have a faster root cause analysis, and distributed trace is an efficient way in order to do it and see all the stack trace of your Lambda services or microservices. Also, you will use OpenTelemetry because maybe you want to use a different tool than X-Ray, and OpenTelemetry is open standard that is used by AWS in X-Ray and that you could use in order to push your trace to any external provider that is compatible to it. And the third point may be that with OpenTelemetry libraries, you can add any custom attributes, span, or log event directly in your Lambda serverless functions, and this could be useful in order to do queries, dashboards, or any analytics based on this information. For example, in Lightstep, we can use the attributes in order to correlate what is the root cause of an incident. Also, you should ask yourself, what are the limitations or impact of using OpenTelemetry in my Lambda services? You should be careful about 3 points. The performance impact, especially during the cold start of your serverless function, may be not negligible. During the runtime, I would say that OpenTelemetry runs in few milliseconds, like a Lambda services, so it's very efficient and very fast. And by the way, if it doesn't work with OpenTelemetry, I think that you cannot use any other agent because that is the fastest that I have found in the market. The second point that is limited is the fact that the Lambda infrastructure steps are visible only from client side. I will come back to this point during the lab, but you will see that the cold start is not visible in the trace that you send to external provider, simply because it happens before the function is ready and before the trace start. Also, there are some context propagation limitation in AWS, but this is not discussed in this lab, but could be the subject of another one where we will show how we integrate these lambdas with a front end or with other services. So what will be the step-by-step approach that we will follow? First, we will enable distributed tracing with AWS X-Ray. Then I will show you how to push the traces outside of X-Ray and to Lightstep through an OpenTelemetry collector. For sure, you can use this collector to use any other endpoint that you want. And finally, I will show you how to add custom attributes and log events in your code. In order to do all this, I have deployed a very simple hello world Lambda function that you can see here, and that is running very well. It just reply Bob to my call. I have also a GitHub site where are all the instructions of this lab. This is OpenTelemetry AWS on the Lambda folder, and I will follow all these steps during this lab. You will see that these steps relies on 2 web pages from AWS that I have regrouped in my lab, plus additional instruction to add your own custom attributes. And I have a fresh new Lightstep instance where I will push my service and my traces at the end of the lab. Okay, let's start the lab. So first, you will have to add a Lambda layer to your serverless function in order to enable distributed tracing. So I go to my function, to the layer side, and I add a layer. I specify a specific layer. So what is interesting and what could change in this layer compared to your? Here you've got the region. So this region, you can obtain it either from your menu here, where you can see that I am in US East 1, or directly when you deploy your Lambda. And here, you've got also the architecture of my service. So you can see my architecture is x86-64. This is translated to AMD 64. If you've got ARM64 architecture, just put here your ARM architecture. So the layer is different depending on the region and on the architecture, and for sure you've got also the version that could be a different one. Verify, it is okay. Now I can add it. Once you have added this layer, you should enable the X-ray configuration. For this, you go to configuration, then to monitoring and operation, and you can see that active tracing is not enabled, so we will just enable it. If it is required to create some new roles in order to make it active, just say yes to the creation of the new roles. Perfect. And the last point to do is to add a new environment variable to enable this. So this is detailed here. You should create an AWS exec wrapper environment variable. So again, you go to configuration, then environment, you edit it. I had my AWS exec wrapper with value linking to OpenTelemetry. Now that everything is good, I just have to test my application and see if the X-ray trace are available. So I test again my application. You can see a difference here because I have a trace ID from X-ray. And if I go to my monitoring and to X-ray, I can see my trace ID, my trace just pushed a few seconds ago, and I can see the distributed trace here with my Hello World application. Perfect. Now we go to the second step, and we will push this configuration to an external backend, and more precisely, we will push it to Lightstep. In order to do this, we will add an OpenTelemetry collector configuration to our project. So first, I will have to create a new folder. I call it OpenTelemetry. And I will add my collector configuration in YAML to this folder. So this configuration, I will take it from the GitHub here. And I will come back to it now. So this is a very basic configuration. First, it receives on the OTLP protocol for both gRPC or HTTP transport protocol. Then it is able to export in log files, in AWS X-ray, and in Lightstep. In order to export to Lightstep, you should define an endpoint, which is a public website of Lightstep. And here I have also to define a token. Finally, to enable all this, I have a pipeline for traces that is able to receive from my OTLP protocol and to export to my three destinations, logging, X-ray, and Lightstep. I save this file. I should create new environment variables in order to enable this. First, I will create an environment variable in order to specify where is my collector config file. Typically here, var task is the root folder for your serverless function, then OpenTelemetry and my collector.yaml file. And the second variable that I will create is my Lightstep access token. Perfect. I have added my Lightstep access token. Now I need to deploy my change, especially my new collector file. This is successfully deployed. Now I will test it again. So you can see again the trace ID for X-ray. If I go to my X-ray page, I go back to trace. Okay. This is my new trace. The time is not exactly the same. And if I go to live step, if I refresh the list of services, yes, I can see my new service dim hello world visible. And if I go to my Explorer, I can see the trace visible here. And if I open it, I can see it. Now we will go back to our Lambda and we will update our code in order to add some trace event and custom attributes. To do this, I also provide a sample of code. So you just have to refer the OpenTelemetry library API library in your code, and then in the code itself you can see that here I will get the current active span. So what is a span? It is this line here. It is one operation. So if you've got several operations like here, each line is normally a span. So I get the active span from my OpenTelemetry context, and I add an attribute to this span. So I will add a name attribute with name event.name1, and I had also a log event. This is a test log event. So I save my change, and I deploy them. So my changes are deployed. I will launch several tests. You can see the resource attribute. Okay. So if I go back to X-ray, to the trace, and here I refresh them, I will see the different traces that I have sent. These are the traces. If I open my Lambda function, if I go to the metadata, I can see here my custom attribute. If I go to live step, I return to the Explorer and I refresh it also. If it takes more time to get your trace in live step than in X-ray, this is normal, simply because live step is made for a high volumetry site, and we've got a little latency between the moment you push the trace and the moment it is visible in the user interface. Most of the time it is around 30 seconds, less than 1 minute. Okay, now I have all my new traces. If I take the last one, I can see my attribute names equals Bob. I can see also my log event here. This is my test log event. Maybe you see also that there is only one span, one operation in live step, whereas you can see several lines in X-ray. This is simply because the only line that X-ray is pushing is your Lambda function, so the last one. All the rest here are infrastructure step, meaning that are the cold start of your X-ray, or that is all the AWS gateways in order to reach your service, meaning that these steps will be visible from the client side. So if you've got a trace from the client calling your Lambda, you will be able to see this additional information, or at least you will be able to capture the latency of these steps. But when you've got only instrumentation in your Lambda itself, you can only see the last step, that is the Lambda instrumentation. Also, what is interesting with last step is that we can use these attributes in order to filter the trace. And here I can see only my last test when I run with the Bob attribute. Be aware that you can also add custom attributes directly in your environment variables. So you can add an environment variable called the Otel resource attributes, and then you can add as many attributes as you want simply by putting them as key value comma separated, like this example. Typically, I use this resource attribute environment variable in order to add the service version of my service. So why is it interesting to add this attribute? Simply because you can detect any regression by using this tag. In last step, we can compare version. We can also detect that there was a deployment of a new version using this service.version tag, and it will be visible directly in your service directory in last step. So that is the service directory. Here you can see that for the moment we have no version attribute. As soon as you will put one, it will be visible here, and you can detect new version and compare or detect regression thanks to this. So I clearly recommend you to add these attributes either in your code or as an environment variable. Thank you for your attention. I hope that this was useful for you.